This is the science teacher. His name is Mr. Amir, and this is one of his students, Rakim. Here is an interaction that took place between the two one day.
So, Rakim, what you know about stoichiometry? We've been covering this unit for a month now.
Mr. Amir, to be fully honest with you, I'm not too sure I know anything. It's all come in one ear and out the other.
Ay, what shall I do? We'll go through a lab that demonstrates all you need to know about stoichiometry, and then you'll come out knowing everything you need. So let's go.
Stoichi, I'm a stoichi. I'm a stoichi. I'm a stoichi. I'm a Trey, what's up?
So, let's understand some basics. What is stoichiometry? Stoichiometry is the calculation of the quantities of reactants and products in chemical reactions. Composition stoichiometry deals with the mass relationships of elements in compounds. Reaction stoichiometry involves the mass relationships between reactants and products in a chemical reaction. Now on to the lab. So, in this lab, my aim was to use the reactants of sodium carbonate and calcium chloride and turn them into a product of calcium carbonate. Then find the theoretical, actual, and finally percentage yield of my reaction. This lab was to demonstrate how stoichiometry works and also explain to me that if concentrations and amounts of the starting materials are known, theoretical yield can be calculated from a balanced equation. So first, I had to write a balanced chemical equation for the reaction of calcium chloride and sodium carbonate. This was how I made my balanced equation. A balanced chemical equation shows us the numerical relationships between each of the species involved in the chemical change. We can use these numerical relationships to write mole ratios, which allow us to convert between amounts of reactants and or products, and thus solve stoichiometry problems, which I'll do real soon in this video. After I got my balanced equation, I then found out the mass of calcium chloride that I would need for the reaction, using this equation that I had constructed. I also found out the mass of sodium chloride that I would need for this reaction, using this equation that I had constructed above. Then I calculated the theoretical yield as is shown. When I was done with my calculations, I got to do the actual lab work. So, I used my reactants and made my product of calcium carbonate, as you can see on the screen. I then measured the mass of this calcium carbonate. This mass of my final product that I have found was going to be my actual mass, which allowed me to calculate the percent yield, which is shown now. So, what does a percent yield of 50.25% mean? A percent yield of 50.25% means that I actually produced half of the amount of product that I calculated I'd produce. Calculating the percent yield can be seen as a way to determine how well one performs a reaction and how close to perfect we can come. So as about halfway to perfect basically. So what is the reason for me being about halfway to perfect and not fully perfect, you might ask? Well, the reason is simply that there will always be extenuating factors in reactions like these. And quite frankly, no percent yield can ever be 100%. That is not to say that your actual yield can't get super close to your theoretical yield. In fact, in some reactions, the theoretical yield can be 90% or even higher in fact, meaning that they were very close to perfect. Pertaining to my experiment, some factors that could have affected my actual yield and the rate of my chemical reaction could be conditions such as the temperature and where I was working, with factors such as the AC on, pressure as well, also the way that I have handled certain materials, and also the fact that Mr. Emanuel mentioned to me that one of the reactants he had gave me might have been contaminated or old to conduct reactions with. Also, I had waited about a few hours more than I was supposed to in this reaction, I believe. Also, one last fun fact that I want to mention is that calcium chloride was our limiting reactant in this reaction, and sodium carbonate was the excess reactant. This means that calcium carbonate was the first to run out. So that's it, guys. Now you know a little more about stoichiometry. And cue the outro.
Stoichi, I'm a stoichi. I'm I'm a tree stoicy. I'm a tree stoicy. I'm a tree stoicy. I'm a tree stoicy. I'm a tree with safe.